Ever just stop and think about why you don't feel the Earth spinning? I mean, really think about it. It sounds like such a simple question, right? But the answer, well, it takes us on a deep dive into physics, biology, and the pretty wild limits of our own senses.
Get this. Right now, as you're listening to this, you're hurtling through space at over 1,600 kilometers an hour. That's way faster than a jumbo jet. And yet, you feel perfectly still. How is that even possible? Let's break down the science behind this incredible illusion that we live with every single second of our lives.
All right, so to figure this out, we've got to first understand just how big the problem is. This feeling of being totally stationary is so powerful, it literally shaped how we saw the entire universe for most of human history.
I mean, for thousands of years, it was just common sense, wasn't it? The ground doesn't move. The sun, the moon, the stars, they're the ones doing all the moving up there. And honestly, it was a perfectly logical conclusion based on what our senses were telling us, which was loud and clear that we weren't going anywhere.
So what exactly are our senses missing here? Well, the first clue to solving this mystery is actually found way up in the sky.
Just imagine you're on a plane. You're cruising along smoothly, maybe an hour into the flight, zipping along at 800 kilometers an hour. You can unbuckle your seatbelt, walk down the aisle, and the flight attendant can pour a coffee without spilling a single drop. It feels completely normal, completely still.
But now, think back to takeoff. That's a totally different story, right? During takeoff, you feel every bit of that motion. You're slammed back into your seat, you feel the vibrations, the sheer force of it all. And that difference is the key. Our bodies are great at feeling changes in speed, acceleration and deceleration. But constant speed? Not so much.
And this gets us to this really cool idea in physics called an inertial frame of reference. When that plane is cruising, you, the seat you're in, the air in the cabin, even the coffee in your cup, everything is moving together as one single unit. Since nothing is moving relative to you, your brain just goes, well, looks like we're standing still.
And yup, you guessed it. That's exactly what's happening on Earth, just on a massive planetary scale. You, the chair you're sitting on, the ground under you, and even the very air you're breathing are all spinning together in perfect harmony. There's no 1,600 km/h wind because the air is coming along for the ride with us. We're all just passengers in the same giant vehicle, cruising at a ridiculously constant speed.
Okay, but hold on a sec. You might be thinking, isn't spinning a form of acceleration? And you'd be right. So shouldn't we feel that? Well, this brings us to the second part of the puzzle, a massive battle of forces happening right under our feet that we can't even see.
So as the Earth spins, it creates this outward force, a centrifugal force that's constantly trying to, fling you off into space. But at the exact same time, you've got gravity pulling you in the complete opposite direction, straight down toward the planet's core. It's a cosmic tug of war.
And what's amazing is just how ridiculously one-sided this battle really is. Gravity is pulling us down with an acceleration of about 9.8 meters per second squared. The outward push from the spin, it's a measly 0.03. I mean, just look at that comparison. It's not even a fair fight.
To put that into perspective, the force trying to throw you off the planet is only about 1/3 of a single percent of the force that's holding you down. It's almost nothing. So the bottom line is that gravity's victory is just absolute. That outward push is so tiny, so completely overwhelmed by gravity's pull, that our bodies have no way of even detecting it. Fun fact, you're actually a tiny bit lighter at the equator because of this, but the difference is so small you'd never ever feel it. Okay, so the physics makes sense, but there's another crucial layer to this whole illusion, and this one's happening right inside your own head. Let's talk about the biology of how we sense motion.
So deep inside your inner ear, you've got this amazing set of sensors called the vestibular system. It's filled with fluid and tiny little hairs that work like a super sensitive biological accelerometer. Its whole job is to tell your brain when you speed up, slow down, or change direction. But, and this is a big but, just like on the airplane, it's got a huge blind spot. Smooth, constant, unchanging motion. Now, this is where it gets really wild. Check out these numbers. For your brain to even begin to notice you're rotating, you need to be turning at about 0.5 degree per second. The Earth, on the other hand, is just casually spinning along at 0.004 of a degree per second. Let me put that another way. The Earth is spinning something like 1,000 times slower than the bare minimum speed your brain's hardware is even built to detect. The signal is just too quiet, too steady. It's flying completely under the radar of our own biology. So, if our senses are totally fooled and our bodies can't feel a thing, how are we so sure the Earth is spinning at all? Well, it's because while we can't feel it, we can definitely see the effects all around us. The consequences are literally everywhere you look. The Coriolis effect, which is a direct result of the spin, is what gives hurricanes that classic swirling shape. If you set up something called a Foucault pendulum, it will look like it's changing direction all by itself, but really, it's the Earth rotating right underneath it. These are big, undeniable proofs of our planet's motion.
And here's a fantastic real-world example for you. Elite military snipers, when they're aiming at a target over a kilometer away, actually have to factor the Earth's rotation into their shots. Why? Because over that huge distance, the Earth will literally rotate a few inches while the bullet is in the air. If they don't account for it, they'll miss. How cool is that? So when you put it all together, this feeling of perfect stillness is really a conspiracy of physics and biology. We're in a perfect state of shared, constant motion. We're glued to the surface by gravity that completely overpowers any feeling of rotation, and our brains simply aren't sensitive enough to notice the slow, steady ride anyway. It's a perfect harmony. And that kind of leaves us with this final thought. This feeling of stillness is an incredibly powerful, everyday illusion. It really makes you wonder, if our own perception can be so fundamentally wrong about the very ground beneath our feet, what other amazing truths about our universe might be hiding right there in plain sight?